We want to make new type of processors. We want to provide processors built from living neurons. And we want that the living neurons will process information. And this will be revolution because it will be very, very cost effective, because it will be much, much cheaper, because living neurons are 1 million times more energy efficient.
Hello, my fellow humans, and welcome to the Multiverse Technology Podcast. Today's guest is Dr. Ewelina, a neuroscientist, entrepreneur, and pioneer in the biocomputing and mental health tech. She's building the future at the intersection of neuroscience, AI, and well-being. Ewelina, welcome to the show today.
Hello, nice to be here.
Thank you. It's great to have you here. I've been really looking forward to this conversation.
Me too.
To get started, if you can kind of give us a little bit of your background and what got you into this work, and then we'll lead into what you're doing right now.
So I'm a neuroscientist by background. I did PhD in brain imaging in the Netherlands. After I moved to London as a scientist, and after some time at King's College, I moved to industry. And I started to work with startups. Initially, I was working on medical image service. That was something I knew very well from my research because of my research was in medical imaging. But that was also the occasion how I learned about artificial intelligence because AI is used a lot in medical imaging analysis. So I learned about AI. I started to go for meetups, for conferences, and I realized that AI is much more than imaging. And I saw how many opportunities are available. And I set up my own company and I started to work on commercial applications of artificial intelligence in industry. And later I started to work also on a step further, which is the future of artificial intelligence, which we see as a biocomputing. And biocomputing is very interesting field, which is combining neuroscience and engineering to make new types of computers.
That is awesome. Very well diverse background, especially in biocomputing. Now,
Yes.
I understand a little bit about that, but not enough to hold a good conversation, which is why we have you on here today to really help us out.
Of course. So biocomputing is a new field. The terminology is not yet established. So sometimes you can find different names on the internet. You can find it as wetware computing or organoid intelligence. But the whole idea is that we are trying to use living neurons as processors. Living neurons, the same as in our heads. We keep them in our laboratory, which is a normal thing for biomedical research, but we have different objectives. We want to be able to program neurons and we want to be able to make computers out of them. And the reason why we do this is because neurons are 1 million times more energy efficient than digital hardware. So we want to make a revolution in AI to make this much less energy efficient, much more energy efficient, using less energy.
I like how you're putting this together with living neurons and AI. I guess what is the overall goal to revolutionize AI with living neurons versus the way we're doing it right now?
So we want to make new type of processors. Today we have processors built from silicon, and we want to provide processors built from living neurons. And we want that the living neurons will process information. And this will be revolution because it will be very, very cost effective, because it will be much, much cheaper, because living neurons are 1 million times more energy efficient. So it will be much cheaper to run such a servers than digital.
Are you guys the only ones doing this, or is this like brand new to the market?
No, we are not the only one, and it's actually good because that's kind of confirmation that maybe this idea is not totally crazy if other people also thought about this. So we have competitors in Australia, which are called Cortical Labs, and we also have competitors in US, which are called Koniku.
I'm interested to know what inspired you to start doing this. And so I know earlier you said that it's a lot faster than silicon hardware, but what is the inspiration behind trying to use this for AI and artificial intelligence?
So neurons are not faster, they're actually slower, but they use less energy. And how it started? So Final Spark was founded in 2014 by two Swiss entrepreneurs, Fred Jordan and Martin Kutter, and they are both engineers, and they had a dream to build thinking machine, which is a dream of many engineers. And they tried, of course, with digital hardware. They did a lot of fundamental research in artificial intelligence, but they realized that it costs a lot of energy. And to make superior AI, you just need more energy. And actually, that's true. We can see that success of ChatGPT is in a big part due to the energy consumption and the big bill for energy. So Fred and Martin realized that if they want to make a difference as a small startup with limited resources, they have to come up with something totally new. And our first employee, Jean-Marc, he had experience. He had some experience with living neurons. He was working with in the lab of Professor Markram, who is very famous neuroscientist in Switzerland. Also initiated Blue Brain project, which is very big project on mapping human brain. And because Jean-Marc had already some experience, they decided, okay, maybe we could try use living neurons. So they get advisors, they set up laboratory, everything from the scratch, and they started to work on trying to build computer from living neurons.
This is so fascinating because I'm used to like regular computer, like silicon hardware, and then we have quantum computing. So I'm
Yes.
curious to know, is there an intersection of quantum computing with this, or this kind of like next generation quantum? Or are they completely separate?
No, I would say they're totally separate. One thing which quantum computing has in common with us, with biocomputing, is that they are both unconventional computing. So these are new ways of computing outside silicon. And I think they're also complementary. So living neurons are good for other tasks than quantum computer.
Now I'm understanding they have this idea because the way the human brain works, they're trying to replicate that. Am I correct? To create
No,
these living
actually,
neurons?
we don't try to replicate human brain. We just want to use the same building blocks as brain, which has neurons, but to build totally different structures. So we would like to build a bioserver, which will be huge. Actually, we want to make structures which will be much bigger than human brain and which will be processing information, but this will not be exactly like a human brain.
I mean, the human brain is pretty efficient and very
Yes, that's true.
complex.
Yes.
Yeah. So, can you explain the energy saving around creating these neuron based computers?
So why neurons use less energy? Because neurons are processing information in totally different way than digital computers. We know that they process information in time and space, so it's important when and where in your brain neurons are active. And also there are a lot of other differences. For example, neurons are much more interconnected. They also have a lot of recurrent connections, which are possible in digital, but much more difficult. There is also such a thing that memory and processing information, it happens in the same place in neurons, while in digital it's separated. So that's also cost energy. So there are a lot of differences which lead to the fact that neurons are so extremely.
Hey, my fellow humans, sorry to interrupt your video, but if you're looking for more ways to protect and empower your healthcare practice, we would love to help. At ITCMD, our mission is to simplify IT, boost security, and support your compliance journey with a human touch so you can focus on caring for your patients. Want to see how easy IT and cybersecurity can be? Schedule a free consult or check out our resources at iteecmd.net. Let's build a safer, stronger future together. Okay, bye.
Efficient.
So fascinating. How do you program these neurons? Like, what are some challenges you found with doing that as well?
Yes, so we interface neurons with digital hardware, and we program them in programming language Python, which is digital programming. So it's not that difficult. And in Python, you write a sequence of things which should happen. For example, when you stimulate, how strongly you stimulate neurons with electrical activity. You also code when you collect the data, how you analyze the data. All this can be coded, and experiments on living neurons can be run automatically. So at the moment, it's more experimental phase because we cannot program too much in neurons. We were able to store 1 bit of information, 1 bit just. So that's not a lot. And at the moment, it's a lot of trial and error, a lot of experiments, how you can program neurons, how you can change the behavior of neurons, the electrical activity of neurons.
Dude, that is amazing. It kind of takes me back to the days of computers where they were first trying to figure out how to use them correctly. And they had
Yes,
a lot of trial and error
absolutely.
with it. Now we're kind of back in that with more advanced technology now.
Yes.
I'm interested to understand the application of this in the real world, not just for AI, but there are other applications that we can use this on. I understand that it's faster, but where can we kind of applicate this on the things that we're using in our everyday lives?
So we believe that all the tasks which are done by artificial neural networks could be done also on living neurons. And we think that all the tasks when the speed is not important because neurons are slow and when you don't need too much in memory, that's our perfect tasks for a biocomputer. And we think about generative AI actually a lot because generative AI is something what is perfect for human brain. We believe that would make a revolution in energy efficient ChatGPT or other LLMs.
Dude, that's amazing. It's gonna be very fun to see this come out and come into play in the market. Are you guys still in the testing phase? Is that correct?
Yes,
Nothing's been
absolutely.
released?
Yeah, it's very long. We just store one bit of information. So, it's very early stage. And we expect Biocomputer to be ready in 10 years, assuming we find investor. We are currently talking to investors and seeking 50 million Swiss francs, which is around $50 million investment. And with that, we can assume that the Biocomputer will be ready in 10 years.
That's amazing. How have you been having success with the investments, trying to explain this to them so they understand it? I'd be curious to understand if you could explain to our audience how you explain it to them to understand.
Yes,
It's a
I
little
think
very complex.
we are quite communicative. That's one of the reasons why we actually talk to podcasters, because we want that the topic is not totally new for investors, because we want that more and more people know about biocomputing. And yes, I think they quite understand, but it's risky investment because it's predicted that it will take 10 years to build a biocomputer. So for many investors, it's a challenge because they would like to see profits in 5 years, which is difficult with biocomputing.
Yeah, 10 years is definitely a long time to wait. And by 10 years, there could be something new or this could even be obsolete by then.
Yes, absolutely. Never know. We never know what will be in the future. Yes.
Yes, I know like with AI intelligence, for example, that's been out since like I think before the 1950s, and people just started now hearing of that,
Yes,
but it's
absolutely.
around for a while. Yeah.
Yes.
What are some ethical considerations you've been encountering with this when maintaining and experiencing with the living neurons?
Yes, absolutely. We get a lot of questions from people, from journalists and from a general audience. And we are engineers and scientists, so we cannot really answer. But we put a lot of effort to get in touch with philosophers, which are perfect people to answer this kind of questions. And maybe there will be study. Some research group is planning a study on philosophical aspects of biocomputing, but they didn't get funded yet. It's still a plan, so I cannot disclose, but we hope that soon there will be some research activity in this field.
Okay, that makes sense. I mean, you're creating the technology and then you're kind of having someone else help you figure out the ethics and stuff behind how to use
Absolutely.
it.
You cannot do everything, but we want to do our best that the work which we do is accepted by society. And if there is anything we have to do to ensure ethical conduct, then of course we will do this.
That makes sense. I mean, it's weird you have a lot of new technology coming out. You don't know how it's going to affect things or how it's going to work or be applicable in the real world. Necessarily, you have like one assumption, like we're going to use it for this, but then it could be used for something completely different, better or worse.
Yes,
You know?
absolutely.
Yeah, you have no way of telling. Anything that our audience can go and see this in action, like any way to like interact with it or anything?
Yes, absolutely. So interaction is sometimes possible. We can always see on our website, finalspark.com, we have section live where you can see a live view from our lab, how it looks from the camera and also the activity of neurons. And sometimes it's not always active, but we have Butterfly. So if you put in Google, Butterfly Final Spark is such a web application where we can interact with the butterfly, which is partly controlled also by living neurons. But this is not always active because we need to keep maintain our lab to do this. So, but sometimes you can log in and you can play with Butterfly, which is partly controlled also with neurons from our lab.
That is very cool. I wish I knew about that before I got on here. I did my research, but there was so much research to go through that you sent me. I was like,
Yes,
whoa, there's a lot.
absolutely.
Yes, there is a lot of when you're doing a project like this, there's definitely a lot of stuff to consider and go through. I want to go back a little bit, kind of understand like before you got started on this project, was there anything in your life that was going to lead you to do this? Or is this something as you were going up, going to school, that you're like, this is what I want to do and work on? Did it find you? How did that kind of go?
So I always wanted to be a scientist as a child, and then I went to study pharmacy and biotechnology, and I went to do PhD in neuroscience. And when I was studying, I realized that the most interesting topic in medical science is human brain. So that's why I knew I want to go to neuroscience. But I always knew that I wanted to also go to industry because I was curious about the world. I wanted to see something else than academia. And then I think artificial intelligence I came across was a perfect topic for me because somehow related with neuroscience, because artificial intelligence actually is somehow inspired by Neurons by Neuroscience. And then actually I was lucky. I was networking a lot. I was educating myself about AI. And then I met founders of Final Spark at a conference in London. And then I thought it's cool also that they combine neuroscience, which is my scientific expertise, with engineering, which is my commercial experience. So that was a perfect project. It looked like a perfect project for me.
That is so cool. And I've always been into like neuroscience, but not, I haven't really gone that deep on it. And I'm still trying to learn so much more about it because it's so complex. I'm curious to know if there
form for researchers, for example, or any kind of form, you always get an answer from us. Also, you can go to the section team on our website and you can see contact details, emails to everyone in our team. So you can ask questions directly. You can also contact us on LinkedIn. So there are many ways to get in touch. We have also a Discord community where there are a lot of discussions, also technical. So we try to amplify the resources so that people who are interested in the topic, they can.
very cool. We'll definitely put that down in the show notes so they can find it. Looking ahead, do you see the living neuron computers working alongside traditional systems or replacing them altogether?
Yes, definitely. I think they will be complementary. So I think in the future we will have a different type of chips. We will have also quantum computers, and they all will be complementing each other.
Yeah, because I know there's so much going on with technology now. Like it's growing so fast. And now I learned about your company and what you guys are doing. It kind of blows my mind. And kind of is a little scary at the same time because I know people are trying to build robots and AI and put this into them to make them faster, more human like, more responsive. I was on a call with a guy talking about AI today recently. And we were talking about how some of the AI can be really dangerous because people don't understand how to interact with it. But as we grow to get more artificial intelligence and robots being more human like, more responsive, we're going to have
Mhm.
more of an issue. What he believed, people are connecting with them on a more of a human level.
I think it's a normal thing in new technology that there will be more layers of abstraction. So it will be easier for people to interact with it. So that's, and also I think that with the new hardware, now to interact with living neurons, you really have to and understand how they work. But in the future, there will be some layers. Like today we have, you don't need to know exactly the hardware. You don't need to know Verilog to program a computer. Digital and the same direction I see in biocomputing. They will be higher level for programming, but also for interaction to make it more intuitive. So I think it's general direction in technology that we have to make it more intuitive so that people can know how to use it without any training.
This is going to be, I see this becoming something really great along the way. Or it's going to be turning into something like Westworld. I really like that show. I can see that happening as well. But is there anything you'd like to leave our audience with or let them know and how to reach out to you as well?
So yeah, LinkedIn or website, finalspark.com. This is the best way to reach out. I encourage everyone who has any kind of questions or maybe comments about our project. They're very much welcome. Of course, also you can rent our lab. You can rent access to our lab if you are an engineer or a company interested in trying to do some research on living neurons and how to interact with them. Or how to have some idea about biocomputing, then we also encourage to get in touch and we are happy to collaborate.
That is amazing. We'll put that in the show notes so they can find that as well. Well, Evelyn, I want to thank you for coming on today. It's been really fun talking with you again to learn about these living neurons and how they can replace our computers in the future and make things faster. It's been amazing talking with you today.
Thank you so much.
That's what I thank you for coming on here. Have a good rest of your day.
Thank you. Bye bye.
Bye.